Hello everyone, today we are going to study organic chemistry, some basic principles and techniques. Today we will discuss about resonance or mesomeric effect and all the things required to do this. We will do all the structures of resonance and let me show and write the definition. At first we will write the definition of resonance and then we will make the structures, okay? We know that resonance is also known as mesomeric effect. Its definition is if a molecule can be assigned two or more structures, none of which is capable of describing all the known properties of the compound, then the actual structure is the intermediate or resonance hybrid of these structures. This phenomenon is called resonance. Let me write, then you can copy it from it. Just write the definition once again. I will repeat this. What is resonance? If a molecule can be assigned two or more structures, none of which is capable of describing the known properties of the compound, then the actual structure is the intermediate or resonance hybrid of these structures. This phenomenon is known as resonance. Let's take an example of CO2. Taking an example, CO2, the structure will be the structure the structure of CO2 will be like this. C double bond O, and here it's double bond O. There are two lone pairs, one two, that one lone pair, and that's two lone pair, one two three four. That's the structure. Now we will do the resonating structure. At first we will do the same, that C double bond O, double bond O, 1 2 3 4, 1 2 3 4. That's the first structure, and give this sign greater than or less than. Now again C single bond O, and here it will be triple bond O. The bond shifted from here to here, and two lone pair gone from here, and a plus sign come here, and the two lone pairs came on this side of this oxygen. 1 2 3 4. At first we have four lone pair, four two lone pairs, okay? And now it comes three lone pairs, 1 2 3, and a minus sign will come here. Again the sign will came, and last structure of this compound, CO2, okay? Now C will become here, and again now this time the triple bond will on the right side of O, and lone pairs with a plus sign, and a single bond with O with a minus sign with 6 lone pair. That's our second structure, and that's the final third structure. We will be taking another example of benzene. We know that benzene is C6H6. Let me tell some new parameters, that what single bond, double bond, and triple bonds of the length of the bond length, okay? See, single bond length will be 139 pm. For C to C, it's observed, first is observed, okay? Second, C to C, it will be 154, and third, C double bond C, it will be 134 pm. That's picometer. Let me draw the benzene. Carbon 1 2 3 4 5 and 6. Give a hydrogen to all of them. Total 6 hydrogen and 6 carbons will be there in a benzene. And alternate double bond here, here, and here, one after the another. Its resonance structure will be like this. Give a double-sided arrow and make the benzene again. Carbon, 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 carbon. Mix all the hydrogen again. Hydrogen, 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 hydrogen. Okay. Now at last stage of the resonating structure, the alternate double bonds will not appear here and they will vanish with electrons coming. Okay. Now from here give electron to here, then here, and that's here, here, and last two electrons will be in the bond, these two bonds. For this electron, this bond, this electron, from the middle one this, and this one, and sides at this two, and make a imaginary line on this so that we can. That's the resonating structure of benzene. Taking another example of carboxylic acid, okay, we'll make the resonating structure carboxylic acid, that RCOOH. Make R, C double bond O, single bond O, and H. 4 lone pairs. Okay. The 2 lone pairs will come here, and this bond will make a came here, and its resonating structure will be R. The bond breaks and it makes a single bond with a negative sign with oxygen, and this lone pair came to here, making a double bond O with a plus sign and 2 lone pairs with hydrogen. I am sorry, I have told that there are 3 pairs. There are total 6 lone pairs of electrons in the oxygen, and here is 4. Make it right, please. Let me take another example, like we will be taking another example, acetate ion. That's ion. I have told ion, that then there will be a negative sign, CH3 COO negative. Okay, let's make this resonating structure. Acetate ion, CH3 C, then a double bond O, and a single bond O. Okay, with negative sign. As I have taken a negative sign, I have taken this negative sign here. Let's take the negative sign with this bond, and the double bond with this oxygen. The resonating structure will be CH3 single bond C, and here the double bond breaks with single bond O, and a negative sign comes, and the negative sign breaks with the O, and comes a double bond here with the oxygen. That's our first structure, and that's the second. The last example, but not the least, this is very important. Mark it important. That's important. I make a star here. That's nitromethane. Nitromethane. Nitromethane CH3 and single bond NO2. Okay. Making its resonating structure, that's CH3 single bond N, double bond O, and a single bond O. The lone this will come here, the lone pairs of the oxygen will come here, and the bond will here with the lone pairs of oxygen. Then the resonating structure will be CH3, and as its lone pair come here, the bond will be doubled, and this bond breaks to make O minus. And again we can say that CH3 single bond N make single bond O, and single bond O make partial double bond. But these are not double bonds, these are partial double bonds. Don't do wrong. Now we will be studying about resonance in substituted benzene by an electron releasing group. Do you know which are the electron releasing group? Let me tell you. Electron releasing group. Next topic, resonance resonance in substituted benzene by an electron releasing group. Okay, let me tell you some electron releasing group. We have to study only the four groups. Okay, electron, I will write it short form: electron, E for electron, R for releasing, and G for group. Okay, these are R, NH2, OH, and OR. There are more, but we will study only four in class 11th. Now, write the definition of resonance substituted benzene by an electron releasing group. Okay, I am writing this definition here. Um, an electron ERG, electron releasing group, causes delocalization delocalization of negative charge. Okay, not positive, it will be negative charge as its releasing group. It will release its electron. There will be negative charge at the position will be at ortho and para positions only. Ortho and para position, not the meta one. Okay, thereby activating these positions, activating these positions. This is also known as plus R effect. You can write it. Now we will take some examples of electron releasing group in substituting benzene and make the resonating structures. Taking example of phenol. Okay, that's example number one. Taking example of phenol. Now look at here how I make the structure of phenol, resonating structure of phenol. At first, draw a benzene. I have drawn a sorry, I have drawn a benzene, and OH will be here as representing phenol. Um, we all know that OH in benzene ring is known as phenol. Okay, OH has two lone pairs. We know that OH has two lone pairs. Okay, let's make the resonance structure. These lone pairs of these lone pairs will come and join on this bond, and this bond, double bond having here, see, this double bond will break and came to this, that's ortho position. Okay, ortho, that's ortho position. Now give a double arrow to here and make the same structure again. Make benzene again. Now a partial double bond will generate here, OH, and that as two lone pairs go on here, here will be coming a positive charge, and the lone pairs of will come here. Okay, and the bond will be uh, the bond will be not there as lone pairs come here. The only bond will left will be here and here. At the resonating structure will start again. The lone pair will come here, and from this bond to para position. Okay, same again, double arrow, make benzene. Now the lone pairs will come at the para position, and it will go here, make the bond will come here and here. and this bond will go to here and make a partial double bond with OH and a plus sign. Give an double arrow again and make benzene again. The lone pair will come here now, and the bond will be shifted from here and here, lone pair from here, and it will be coming here. Here the partial double bond OH plus, and it will go to here. That's now the last step. In the last step, make a benzene. Okay, the we have done that. The bond are here, here, here. Okay, but at last the bond will be changing. There will be no partial double bond. Okay, there will be no partial double bond. Bond will be changing from here to here, here, and here. All the structures of benzene with an X group will be same. Um, Taking another example, and this will be the last example of the resonating structure of electron releasing group. Okay, I am taking anisole, and I will give two homework to you. Then you will done. The structures are same for all of them. I am taking anisole. Okay, anisole. What is anisole? In benzene, in the benzene ring there is OCH3. Okay, make a benzene. I have make a benzene. Here will be OCH3 having two lone pairs of oxygen. Make the bond again. The it will be same. The lone pair will come here, and the double bond will break to from here, and the lone pair will come here. Making again. Now OCH3 will be having a plus charge, and the electron will come. Lone pairs will come here. Double bond will be here and here. It will come here, and the double bond will be breaking from here to para position. Now again make a benzene ring, OCH3 plus. Okay, now the double bond will come here, and the lone pairs will come here. Make it from here. The double bond will break from here to this one. Next, I make a benzene ring. The double bond will be shifted from here and then here, and the lone pair will come here. Okay, the lone pair will come here, making this. There is always OCH3 plus, and it will be going here. Now last resonating structure I am making here, that's A, B, C, and D I will be making here. Okay, make again the benzene ring. There will be OCH3, and the alternate double bond changes from here to here. Let me show zooming from here it will come to here. Okay, let me zoom out. Now the bond will come here, here, and here. That's the resonating structure. Last, that's D. That's the resonating structure of phenol. 4 1 2 3 4. I'm giving you two homework of electron releasing group. Make their resonating structure please, and put in the comment that you have done. I am writing here homework will be for you. There will be aniline, 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 and another one is we have done initial phenol, and that's another one is chlorobenzene, chlorobenzene. In benzene ring there will be chloro Cl at the top, and aniline, there will be NH2 at the top having two lone pairs, and Cl will be having two lone pairs. Okay. Now we are going to another topic with the same. We have done what we have done. Electron. What we have done? Electron releasing group. Now we'll be doing electron withdrawing group. Okay. We have written the resonance in substituted benzene by an electron releasing group. Now we will be doing electron withdrawing group. Please do the same, write it same for electron withdrawing group, except you will write positive charge in electron withdrawing group, and the position will be always same for both of them, but the sign changes. And in electron withdrawing group there will be plus sign as it's withdrawing the electron. Let me write for you that positive charge and the positions will be same for both. Okay, write it from here, from the previous one. Let me tell you the electron withdrawing groups. Which are the electron withdrawing? There are four only. The which number one is NO2, second one is C double bond H, third one is CO, and etc. Uh, we study only three in class 11th, and NO2 is the most important. Okay, and let me tell you here, NH2 is most important in our class 11th. In releasing group and in withdrawing group, NO2 is more important. We will be doing first NO2, that's nitrobenzene. Okay, it's an example. We are doing the resulting structure of electron withdrawing group, that's nitrobenzene. What's nitrobenzene? Okay, make a benzene ring first with alternative double bonds here. Make the bond from here only so that you can do the resulting structure at good. Make N double bond O and a single bond O will come here. The resonating structure of nitrobenzene of electron withdrawing group will be starting from this double bond of O to lone pair of oxygen. Okay, and this bond will come here. Now we are making another benzene ring. Let me show you. The bond breaks and the partial double bond came here, and as the double bond breaks from here, single bond will come and a negative sign will appear here, and that's O, which is presented here, and a plus sign will appear at the ortho position, and double bond will be shifted from here to, and these two bonds will be here. This double bond will go from here to here. Okay, that's the first structure of a resonating. Then the second one, make again the benzene ring. Now the bond will come here and here only with partial double bond with N and O and this O. Okay, the bond will come from here to here only. That's our second structure. And the third one, the plus sign will come at the para position and the minus sign will disappear from here. The next, now again make a benzene ring. Now the bonds will be here and here, and now the both of oxygen will having a negative sign both, and this partial bond breaks from here to here, and the plus sign will come here. Okay, as you know that that's a withdrawing group, there will be a positive sign. As I have told you, last structure, last and final, make a benzene ring again. uh, Now the alternate bonds will be changed from, as it's here, it will come from here, then here, and then here. Okay, as, and the structure will be like this. That's the final structure of uh, nitrobenzene. You can copy it from here. I will be doing another example for you, and rest of them I will give you as homework. I will give 2 or 3 as homework. Okay, I am doing now the benzophenone. Okay, I am doing benzophenone. You will do benzoic acid, acetophenone, and benzaldehyde. I will write it for you, and we will do these three. I am going to do benzophenone. Our second example of electron withdrawing group is benzophenone. Benzophenone. That's C6H5 CO C6H5. Okay. At first, draw benzene with alternate double bond with C. It will be C double bond O, single bond C6H5. It will be same like nitrobenzene. The first, the resonance structure will be starting from here. Sorry everyone, from here and next to here. Okay. Now the second one, make again a benzene ring, then make a partial double bond, and this bond breaks as O will be giving a minus sign and C6H5. The positive sign coming with the ortho position, and the double bond will be coming here. This double bond will go here, and we will be giving next make a benzene ring again. The double bond will come to here, and the positive sign will become in the para position. The partial double bond with C, single bond O negative, and single bond C6H5. Okay, this double bond breaks to here, and the next structure will come as again a benzene ring. Sorry, again a benzene ring with bonds here and here, and a partial double bond with C O negative and C6H5. This partial double bond breaks here, and positive sign came at the ortho position again. Last structure and the final, it will be benzene, but the alternate double bond change. I have repeatedly told you that from here we have alternate double bonds from here, but at the last the alternate double bond changes from here to here. Please make it. Please make it, all of you. It will be C double bond O and C6H5. That's the last letter. This plus sign is for ortho position. Sorry, para position for this structure. This is not the plus sign for this. Okay, that's the final. I am giving you three homework. Please do it. That's benzaldehyde. First one is benzaldehyde. That's Ca6H5 CHO. Okay. Second one is benzoic acid. Benzoic acid. That's C6H5 C double bond OH. And the third one is the third one is acetophenone. Acetophenone. That is C6H5 COCH3. That's all about resonance. We have done all the things of resonance: withdrawing group, releasing group, and etc. etc. We have done the definition of resonance, resonant effect. We also know that resonance is also known as a mesomeric effect. Now you can do all of these things. Practice most questions, and please watch this video fully. If you like this video, please subscribe my channel and hit the bell icon, and give a comment if you've done the homework. Thank you for watching. We'll be coming in the next video